Hello and welcome everyone to another video on functions. In this video, we are going to discuss about average rate of change and linear functions. So the average rate of change of a function f of x with respect to x over the interval from x equals a to x equals b is given by this formula right here, which is f of b minus f of a over b minus a. And it basically means the numerator is the change in the function value and the denominator is change in the independent variables. Or in another word, we can say this is change in y and this is change in x. So in graph, we can represent this as, so let's go ahead and draw a graph. Let's say this is the curve f of x. Then if we have a x value a here, the corresponding point here on the graph is a comma f of a. And then let's take another point here b. The corresponding value or the point on the graph is b comma f of b. Now, by the definition, the average rate of change is f of b minus f of a over b minus a. Now, if we draw a line passing through those 2 points, so let's draw a line going through these 2 points. So this line is called secant line. And basically, this expression here, f of b minus f of a over b minus a, just represents the slope of that secant line. We have 2 points on that secant line, so this is same as y2 minus y1 over x2 minus x1 for this line. So basically, this average rate of change represents the slope of the secant line passing through those 2 points, okay? So let's look at an example. So here's a function given to us, f of x equals 2x squared plus 2x minus 11, and we are asked to find the average rate of change on this interval. So if we look at the formula, it is f of b minus f of a over b minus a. So basically here, this is a and this is b. So all we need to find is f of b and f of a. So let's go ahead and do that. So let's go ahead and find f of b, which in this case is f of 0, that equals 2 times 0 squared plus 2 times 0 minus 11, and that gives us negative 11. And then we need to find f of a, and a in this case is negative 2, so we are going to find f of negative 2, which equals 2 times negative 2 squared plus 2 times negative 2 minus 11, and then we get, so negative 2 squared is 4 times 2 is 8, minus 2 times 2 negative 4, and that is minus 11, and then that gives us negative 7. So the average rate of change, average rate of change is f of b, in this case is f of 0, minus f of a, which is f of negative 2, divided by b minus a. And then that equals f of 0 is negative 11, minus f of negative 2 is negative 7, so that becomes plus 7, divided by 0 minus negative 2 is positive 2. So you get negative 4 over 2, which is negative 2. So the average rate of change of that function on that interval is negative 2. Or in another word, the slope of the secant line going through those 2 points on that curve is negative 2. We can also find the average rate of change from the graph. So in this question, we are asked to find the average rate of change for the given function on the graph. from x equals 0 to x equals 2. So x equals 0 is right here, and x equals 2 is right here. So what we need here is we need to find f of b, and b is 2 here. So f of 2 equals, so when x is 2, the y value here, we can just find that from the graph. So the corresponding y value is 5. And then f of 0, the corresponding y value is 1. So that means average rate of change equals f of b, which is f of 2, minus f of a, which is f of 0, divided by b minus a. And f of 2 is 5, minus f of 0 is 1, divided by 2 minus 0 is 2, and that gives us 4 over 2, or which is just 2. So in other words, this means if we draw a secant line going through these 2 points, this does not look like a straight line, but yeah, the slope of this line is 2. So now, in more general, this average rate of change can be expressed as a difference quotient, which exactly means the same thing as average rate of change. Okay, so let's go ahead and draw a graph here, and then let's see what we are going to do here with this difference quotient. Okay, so let me draw a curve here. Let's say here we have a function f of x. Now, in the previous slide, we looked at the average rate of change is f of b minus f of a over b minus a. So if this is a and if this is b, then that's how we get. So, but instead of taking a and b, let's go ahead and say instead of a, let's say I have x. And then let's say b is at a distance of h from x, or this distance is h. Now instead of writing b, I can write this point as, so if this is x and the distance from x to this point is h, then I can write that point as x plus h. So now the corresponding point on the graph is of this point here, the x value is just x, and the value of the function is f of x. Similarly, the corresponding point for x plus h on the graph is the x value, or the first coordinate is x plus h, comma, the y value, or the value of the function is f of x plus h. Now, if we apply that average rate of change formula here, then f of b is f of x plus h, minus f of a is f of x, divided by b is x plus h, minus a is just x. Now this gives us f of x plus h minus f of x over h. And this expression is known as the difference quotient. So again, it just represents the slope of the secant line passing through those 2 points. So if I draw a secant line going through these 2 points, so this one just represents the slope of that secant line, and it's called the difference quotient. So let's go ahead and evaluate a difference quotient, find a difference quotient for a given function. So here we are given a function f of x equals 2x squared minus x plus h, and we are asked to find and simplify the difference quotient, and here is what we are finding. Okay, so if you just look over there, so h is just h, we don't have to do anything, we can use it as h. F of x is already given to us, which is this expression here. So all we need to find here is f of x plus h, and we already know how to do that. We know how to evaluate a function, so let's go ahead and do that. So f of x is given to us, which is 2x squared minus x plus 3. Now we are going to find f of x plus h. So when we do that, we basically, what we do is we'll take this quantity and then replace x with that quantity right here. So that gives us 2 times x plus h squared minus x plus h plus 3. That equals 2 times x plus h squared means x plus h times x plus h, which gives us x squared plus 2xh plus h squared. Then we can distribute that negative here, so we get minus x minus h plus 3. And then if we distribute that 2, we get 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now, if you look over there, we really cannot simplify. There are no any like terms that we can combine, so we'll just leave it there. Now, our goal is to find the difference quotient or evaluate this expression. So we are going to find f of x plus h minus f of x divided by h. Now, f of x plus h is just this quantity right here, or this expression right here. So we'll just copy that. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Then we have minus, just be careful here, we are subtracting, so we have to use a parenthesis, minus f of x. And f of x is just 2x squared minus x plus 3. And everything divided by h. So let's go ahead and simplify this. So we get 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Now when we distribute that negative sign, we get minus 2x squared plus x plus 3. Everything divided by h. Now we'll be able to simplify this. There are some like terms and then the opposite, so we can cancel them. So we have 2x squared minus 2x squared, which gives us 0. Then we have negative x plus x, which gives us 0. Then we have, sorry, this should be minus 3 here, okay, when we distribute that, that's minus 3. So negative 3 and positive 3, that goes away. So whatever we have left is just these three terms here. So that equals 4xh plus 2h squared minus h divided by h. So this becomes much simpler. Now what we see in the numerator is we have h in all three terms. That means we can factor out h. So when we do that, we get 4x plus 2h minus 1 divided by h. And then we can cancel out this h. So the final answer that we get here is 4x plus 2h minus 1. And this is the difference quotient for that function. This is very important when we get into calculus 1. So you really need to know how to evaluate difference quotient. Now, the next thing that we are going to talk here in this video is the linear function. So the linear function is a function that's in the form f of x equals mx plus b, where m and b are constants. So anything like this, we can write f of x equals, let's say, negative 3x plus 5. So this is a linear function. So the exponent of x is just 1, and then we have a constant. So there are two different special linear functions that we usually see. The first one is if m is 0, or this is also known as slope or the rate of change. So the rate of change of a curve is a slope when it's a line, okay? So this is the rate of change, average rate of change, or the slope. So if the slope is 0, if this is 0, then that function just becomes f of x equals b. Or this is also called a constant function, because no matter what x value we take, we always get a constant value. So if you graph that, that looks just like it's a horizontal line. So if this is b, that y value is b, then this is the graph of y equals b, or f of x equals b. So that's how the graph of constant function looks like. It's the horizontal line. And then if m is 1 and b is 0, then the function becomes f of x equals x, which basically means y equals x, or x and y are always equal. So this type of function is called identity function. And the graph of identity function is a line going through the origin making 45 degrees angle with the x-axis. Okay, so this is y equals x. So it means if I pick a point here, the x value is same as y value. If I pick any point on the line, the x value and the y value are always equal. That's what this means, okay? Now let's look at an example of linear function. So this question is asking us, okay, so suppose that a company manufactures radios and sells them for $180. So that's the selling price or the revenue that we are going to get by selling one radio. And then the cost for producing radios, this is the cost. So we have a basic cost of 40,000 and then $100 cost for each radio. And then we are asked to find the profit function if we produce and sell X number of radios, okay? So we have three things here. The first one is the revenue, or the amount that we get by selling X number of radios. So let's go ahead and represent that by R of X. It's a function, revenue function. So this is quite simple because we know that we are selling each radio for $180 and we are selling X number of radios. So the revenue is 180 times X, which is just 180X. And the next function that we have here is the cost function. How much do we invest? Okay, so let's represent that cost function by C of X. So the cost is, we have a basic cost, no matter how many radios we produce, we have a basic cost of 40,000 plus then there is a cost for each radio. So $100 for producing each radio. So we are producing X number of radios, so that cost is 100 times X, which is 100X. Now we are asked to find the profit function. So the profit function, that's right, P of X equals, so profit means how much you get in revenue minus how much you spend on producing thing, or the cost. So P of X equals R of X minus C of X. Now R of X is 180X minus C of X is 40,000 plus 100X. Now if we simplify this, we get minus 40,000 minus 100X, and then we can combine this one and this one, so that gives us 180 minus 100 is just 80X minus 40,000. So this is the profit function, and it's a linear function. We'll just do this much for this video. I'll see you in another video.